Phononic demos solid-state cooling solution on AMD Ryzen 9 9950X CPU. 2x cooling performance versus 240mm AIO. The era of mainstream solid-state cooling solutions is upon us, with Phononic demoing a new tower-type cooler that offers twice the performance versus a 240mm AIO cooler running on an AMD Ryzen 9 9950X CPU. Solid-state cooling solutions see mainstream applications, deliver 2x the cooling performance on AMD's high-end Ryzen 9 9950X CPUs within a standard tower-type heatsink. Solid-state cooling solutions have been gaining momentum, especially with firms such as Frore Systems showcasing lots of innovation in this space. Now, Phononic has introduced its own solid-state solution, which it says will offer disruptive and scalable cooling platforms with both passive and active designs. The cooling requirement in the tech industry is growing at a rapid pace. Modern AI data centers and solutions require more cooling capabilities, leading to bigger and power-hungry solutions to sustain them. Previous generation data centers consumed 40 kilowatts per rack, and the upcoming generation will consume even more power, around 120 kilowatts per rack. That's a 3x increase, and even using the best case solution, the industry can only achieve 66 kilowatts per rack due to given cooling limitations. 40% of the power budget in data centers goes toward thermal management, and it's time that companies start investing in innovative solutions to sustain themselves. Conventional setups currently use either air or liquid cooling. Air cooling is mostly used in passive solutions and is reaching practical limits. That is driving the need for liquid cooling solutions, as we have seen most NVIDIA Blackwell I platforms integrate custom liquid loop designs. Passive cooling solutions are capped by ambient temperatures, while active cooling solutions can lack resolution and lead to overpower. Phononic introduces its solid-state cooling solution, which provides both passive and active thermal management. In passive mode, the Phononic solution capitalizes on the intrinsic benefits provided by ambient cooling and is designed to sustain a chip up till its compute profile within the throttling limit. Once the throttling limit is exceeded, the solid-state solution can switch into active cooling mode, providing a much better compute profile while retaining temperatures below throttle limits. This leads to better power savings while delivering higher cooling and performance when needed. So how the cooling solution works is demonstrated in the Hex 2.0 CPU cooler, which is a 92mm heatsink in a tower-type design. The passive is essentially lets the primary heat exchanger do the work, while the active mode enables the solid-state heat exchanger. The cooler measures 125 by 112 by 95 and weighs 810 grams and houses a central 92mm fan with a 4-pin PWM connector, which has 2 PWM modes, a max range of 2650 RPM, 33 dBA, and an idle range of 1000 RPM. And LT:17 dBA. The airflow is rated at 44 CFM with a 3.1mm H2O. Phononic demonstrates its Hex 2.0 solid-state CPU cooler running an AMD Ryzen 9 9950X CPU, which has a default TDP of 170 watts. The solid-state solution provides twice the cooling performance per fan area versus a typical 240mm AIO, and 50% better performance versus a typical 90-120mm air cooler. The AMD Ryzen 9 9950X CPU peaks at around 80C by default, as we have seen in our review, so this solution can enable a new generation of solid-state powered air coolers. Other form factors include 2U and 1U server CPU heatsinks, which will have both passive and active, passive modules housed in one unit that can be deployed and scaled up for existing and future data centers. It's not just CPUs. Phononic also says that the technology can be implemented on GPUs and can eliminate throttling while extending life expectancy and offering increased power density. Overall, the solid-state cooling solutions are definitely something to look forward to, and while we may see them being implemented on data centers first, it will be great to see certain mainstream consumer products to see if they can become viable next-gen standards for today's traditional air and liquid cooling hardware.